Good morning, and welcome to the Oak Grove Cemetery here in La Crosse, Wisconsin. This morning, I'm going to demonstrate to you the process for taking your photographs for creating a 3D model of a grave monument like the one we see here. We're going to be using 3D photogrammetry, which is a process of capturing 3D geometry using a whole series of photographs. Perfect day for 3D scanning. It's more or less overcast. We have a little bit of sun peeking through now and then. But the overcast skies give us a nice uniform lighting, so we don't have to worry about a lot of shadows in our scan. We're going to start off this series by showing you how to take the photographs in the field. Essentially, you're going to watch me walk through the process of taking these photographs. In order that we can have a scaled model of our grave monument, we're going to include a known scale in our photographs. In this case, I've got a scale bar here, or scale that's got two different types of scales on it. I've got a typical bar scale here that's labeled at 15 centimeters, but then I also have these two binary markers or targets that the photogrammetry software can recognize in the images and find the exact centers, as well as read the binary encoding to tell it that it's marker number 109 and marker 110. Now these markers are placed exactly on this scale at 320 millimeters apart. So if these are in the photographs and the software can find them, we know the distance between them in the real world, and we can tell the software that they were 320 millimeters apart. If we don't have these fancy binary markers, we can use just a known distance of any kind in our photographs. We could use a yardstick, we could use a ruler, anything that you know the exact measurement of that you can tell that you can find in your photographs and mark for the software, and then tell the software what its real world distances are. Now, as you can probably hear, we also have the grounds crew is out doing work on the cemetery today, so it might be a little bit of background noise as we go through this process. These scales, you can see I've laid out two on the ground already. I'm going to put one further one here on the other side of the monument. You don't necessarily need to have three scales. One will do, but three can help better in terms of giving you a nice, giving the software more measurement data to use to scale your 3D model. Now, as 3D photogrammetry relies on photographs, we've got a camera with us. In this case, we're using a Canon EOS Rebel T7i, 24 megapixel DSLR. Takes great photographs, gives me a lot of control on settings, but you don't need something fancy like this. You can do it with just a typical cell phone and get really good results. So, as I said, what we're going to do this morning is I'm going to walk you through the process live. I'm going to take the photographs, talk to you while I'm doing a little bit to explain to you why I'm taking photographs in a certain way, and then you'll see the process start to finish. And then follow-up videos will show you how to use the software to process those photographs. One note though, as you go through this process, if you have a DSLR like this or any camera in which you can adjust the focal length for zooming or wide angle, you want to make sure that you're not changing that during the process. While the software can deal with some of that, it can get confused if you do that too much within one photo set, and it also can lengthen the processing time. So in this case, I've just got my wide angle to zoom lens, and I just have it pegged on the wide angle setting of 18 millimeters. So let's go ahead and let's get started. So a monument like this, I'm going to start out wide, and then I'm going to come in for the detail stuff. The wide gives the software the ability to align a lot of cameras around the monument and give it that larger perspective that then when you do closer in shots that are not including the entire monument, it has the information, the imagery information, to be able to put those detailed shots in where they go on the monument. So the process is simple. We're going to walk around the monument taking a series of photographs. You want to shoot for around 36 to 40 images, roughly, as you go around your monument. That's the equivalent of a photograph every 10 degrees of a circle, which gives you approximately 60% overlap from one photograph to the other. So let's go ahead and get started. I'm going to start out here, as I said, out of a larger, wider view of the monument. And I'm just going to step around the monument, taking photos, making sure to try and include the monument in the frame of the photograph such that the monument takes up the majority of the available screen real estate. That way, there's the maximum amount of pixels on the monument in each photograph for the software to use to start reconstructing its three-dimensional geometry. If I were really, really far away from the monument, the monument itself would take up very, very few pixels in each frame, and we would get a very low resolution result in the scanning process. So thereafter, I've finished our first ring or orbit around the monument. I was looking slightly down on the monument from a slight angle, as you can see. Now I'm going to do a ring a little bit closer in, still, again, trying to frame the monument so that it fills most of the frame of the camera, while trying not to cut too much off in this case. I want to get another ring, but this ring is going to be more at a lower angle, looking straight in on the monument. That first ring also had the advantage of making sure to include those scales and being able to look down on them, which will give the software the maximum capability for finding those scales in multiple photographs each, which is important. Because as you're photographing your monument, you want to keep in mind that the software cannot reconstruct the three-dimensional geometry of a point if it can't find that same point on the monument in at least 2, preferably 3 photographs. So I'm just continuing around the monument, framing each photograph, making sure I'm holding the camera steady so that I'm not getting any blur in my photograph, because you want your photographs to be in as sharp a focus as possible. Blurry photographs result in very bumpy 3D models in the end. You also want to make sure, if you can, if you're using a camera where you can control the focus point where the camera is focusing, you want to be focusing on the monument itself, not on a distant object, so that the monument is perfectly in focus as much as possible front to back. Okay, so there I've completed our second ring of photographs. Now I'm going to do a few photographs looking straight down on the monument, just to make sure that I have the top of it from a high angle, so I'm not missing any top pieces. Very important when you're dealing with taller monuments. Try and get up there with your camera to be shooting down on it. Following that, I'm going to come in and we're going to do some detailed shots close up of the inscription and the high relief carving here at the top. Now, in the case of these more straight down photographs, I'm not as worried about including the entire stone in the photograph, because I'm really looking to capture the detail here on the top, but there's still enough of the monument visible that the software will be able to align these images with the others. Now, it's also important to point out to you that as I move around this monument, I'm making sure that my feet are not in any of the photographs, because we don't want the scene changing from photograph to photograph. If my feet are in it, then my feet are in a different spot each time, and that can confuse the software. The other thing I'm making sure not to do is to kick these scales. If the scales move, the software is going to try and deal with that movement, and it won't be able to align the images properly either. So I've gotten my shots now that give me this top pretty well. Now we're going to take some detailed shots here on the front. Now, instead of going in a circular orbit here at the front, what I'm now going to do is do straight on shots first with about 60% overlap from side to side, and I want to go for at least 20% from top to bottom. I'm just going to take one photo, move over about 30%, 40% of the frame each time, and then I'm going to move down a little bit, go back the other direction, and continue that process down through the entire inscription. Now this serves the purpose of making that inscription cover lots of pixels within the image, so that it has more pixels to try to find the three-dimensionality of any point within the image. Because this is fairly high relief carving, I also want to make sure that I'm not just getting pictures from looking down on it, which is capturing the top, but I also want to get some shots looking at an upward angle to catch the bottom of the carving here. Otherwise, the software is going to have to interpolate that, and it may or may not do that successfully. And that should be enough to really capture the bottoms of all of that carving. Also going to get a shot here on the bottom sides of the letters. Now you may have noticed that I've held the camera in two different directions. Doesn't make a difference. The software is able to figure out that the camera has been turned and align those images properly. So that's the basics of photographing your monument for 3D photogrammetric scanning. As I said in future videos, we'll run through the process of running the images through the software to create our 3D model. Also going to go around and show you a few tombstones to show you some issues that you might want to think about when scanning very complex stones. This is a fairly simple stone. There's not a lot of detail to it. There's not a lot of challenges to it. Some other stones have some particular challenges to them, and we'll add that into another video.